Today we will learn how to use squaring techniques and reciprocal techniques to help us in the process of graph sketching. Now let us consider this graph y equals to x. And we are supposed to transform this graph y equals to x to y equals to x squared. Now y equals to x squared can be transformed by squaring this function. Now let's consider this point where y is equals to 0. Now if you square this point, still remains the same. It is still 0. So this point stays unchanged. Now there's another point that stays unchanged, is the point 1. Now when y equals to 1, if you square, it is still 1. So this point doesn't change. Now how about points when y takes a value that is less than 1 but greater than 0? Let's say a number. Let's say y is between 0 and 1. When you square, what will happen? It is still between 0 and 1. It will not get out of this boundary. It will be equals to 1 if y is 1. It will be equal to 0 if y is 0. But you realize that y squared will always be smaller than y if y is between 0 and 1. Now it will be equals to y if y is 0 or 1. Other than that, y squared will always be smaller than y if y is between 0 and 1. Take for example, if y is half, y squared will be a quarter. If y is 1/3, y squared will be 1/9. 1/9 is smaller than 1/3. So anything between 0 and 1 you square, you find that it will be below this y equals to x because it's smaller than itself. But it will be equals to itself when it is equals to 1. Now anything above that, alright, above 1, you square, it will be greater than itself. That one is quite intuitive. But for this between 0 and 1, it's not so intuitive. So anything above 1, it will be greater than itself. So it will be above the line y equals to x. So your graph will look something like that. Okay? Now, this is y equals to x squared. Now, how about this side of the graph when x is less than 0? It is just a reflection because y equal to x squared is a even function. Now let's try to draw the graph y is equals to x to the power of 4. Alright, y equals to x to the power of 4. Now we can derive this graph y equals to x to the power of 4 by squaring this graph y is equals to x squared. Now for anything between 0 and 1, if you square, it will be smaller than itself. So you will find that y to the power of 4 will be less than x to the power of 4 will be less than x squared when it is between 0 and 1. So you find that this part is less than the yellow graph. But when it is at 1, alright, it coincides. Because square of 1 or 1 to the power of 4 is still 1. But anything above that, you find that it will be above the yellow line, yellow curve I mean. All right. Now this side is the same. It will be a reflection. Okay. Now let us try to draw the graph y equals to 1 over x squared. No, y equals to 1 over x first. Then after that, we will square the y equals to 1 over x to get 1 over x squared. Now for 1 over x, let's say this is 1 and this is 1 because y equals to x. So this point will be 1, 1. Now, now we are trying to draw the graph y equals to 1 over x. Let me write over here. Now 1 over 1 is still 1, so this point doesn't change. But how about the x-intercept? Now, it will not be defined if x is 0. Okay, so this one will be a asymptote. Now when x, now we are supposed to do the reciprocal of this graph. Okay. Now when y takes on the value of, let's say, 0.0001, you 1 over that value is super large. So it is somewhere here. Now when y is extremely large, all right, when y is extremely large, you must consider, we are doing the 1 over y, reciprocal. Okay, we are not considering 1 over x. Now when y is extremely large, you 1 over that, it will be extremely small. So your graph is something. Now bear in mind, we are not trying to draw this graph 1 over x directly. We are trying to transform it from y equals to x. So you must consider 1 over y. All right, we are trying to do the reciprocal. Now how about this side of the graph? It is the same. All right, when it is at -1, when y takes a value of -1, you 1 over -1, it doesn't change it. So this point remains unchanged. Now when y is very small, you 1 over that number, all right, it will be very large, but this number is negative. So it will be negatively large. Now likewise, when it is extremely large, when y is extremely large, you 1 over that will be very close to 0, but it is negative, all right, y is negative. So this will be very close to 0 but negative. Okay. Now next, let us try to draw y is equals to 1 over x squared. Now, it can be obtained by squaring this function. Okay. Now we must try to do the squaring of the function, not sketch it directly. The purpose of this is to let you get used to squaring function and 1 over, do the reciprocal of the function. Now, let's say this point 1, you square of it is still unchanged. Huh? Now this is, y is -1 here, -1. You square it becomes 1. Right? Now, what happens if y is between 0 and 1? You square, it will be smaller than itself. So it will be below this pink graph. Now, when y takes value that is above 1. You square, it will be larger than itself. So it will be above the pink line. Okay, so your orangey yellow color, line is y equals to 1 over x squared. Now, for this, it's just a mirror reflection. Now, of course, you can try to do it by deriving the, what you can do is, no, this is less than 0, all right? What you can do is you can do a flip, all right? Because when you 1 over x squared is always positive, all right? You square this function will always be positive. So you flip and then you do a square, just like this side, and you will get the orange curve too. I'll leave that to you. Next, let us try to sketch this graph x to the power of 4 minus 6x squared plus 9. This expression looks rather intimidating because it's to the 4th power. But if you look at it closely, this can be rewritten as x squared minus 3 whole thing squared. Now, I'm sure you can draw x squared minus 3. After that, what we can do is we try to square the function, and from there we can deduce how a graph looks like. Now let us draw y equals to x squared minus 3. Now first we draw the graph y equals to x squared, and then we shift the graph down by 3 units. So you find that the minimum point and the vertex will both be at minus 3. And the roots will be at minus root 3 and root 3. So your graph will look something like this. Now next, we will try to square this function. Now assuming that x is equals to 1 is somewhere here, or y equals to 1 is here. Now so you find that this point doesn't change if you square it, because y is equals to 1, you square it, it is still equals to 1. And so is this point. And this point too. Because this is y equals to 0, you square it is still 0. But how about this point here, y equals to minus 3. You square now, it becomes 9, so it becomes much higher now. Okay? Now how about points between 0 and 1? You square, it will be smaller than itself. So it will be below this graph here. Alright? So this thing will be below. Now, next, how about points that are above 1? You square, it will be bigger than itself. So it will be above. So the graph will look something like this. Alright, likewise here, it is greater than 1, you square, it will be bigger than itself. Alright, looks like a W. Okay. Next, let us try to sketch this graph. Y is equals to 1 over x squared minus 3 squared. That is the reciprocal of this graph. Now let me transfer this the x-intercept down first, because it will be an asymptote. So I will not use this, draw it over here, because it's already too crowded. Alright, so this is minus root 3 and this is plus root 3. Now you are doing a reciprocal of the graph in pink. So right over here, it is slightly bigger than 0. When you do a reciprocal, it will be extremely large and positive, so it will be somewhere here. Now this graph right over here, alright, this is the asymptote. If I project up, alright, to the right of the asymptote, or rather to this part when x tends to very large, you do a reciprocal, it will be extremely small. So your graph will look like that. Okay. Now let's draw the left hand side of the asymptote first. Now this is slightly larger than 0 and positive. So you 1 over that, it will be extremely large. And this is extremely large over here. When you 1 over that, it will be extremely small. Now this is, you square of this becomes 9. Now 1 over 9 will becomes 1/3. So it will be much lower now, 1/3. Now what happens when it's slightly to the left of my root 3? You find that this is very close to 0. You 1 over that, it will be extremely large. And likewise, you can do when it is slightly larger than minus root 3, alright, to the right of minus root 3. You find that the shape of y equals to 1 over x squared minus 3 whole thing squared will be of such. Let me do a summary for all that we have learned. Now this is f of x, this is 1 over fx, and this is f of x squared. Now for the x-intercept of f of x, it becomes the asymptote of 1 over fx, because 1 over 0, because f of x will be equal to 0 when at the x-intercept. So you cannot do 1 over 0 is undefined. So 1 over fx becomes the asymptote at the x-intercept of f of x. This one remains unchanged. It is still the x-intercept of f of x squared. When f of x equals to 1, 1 over f of x is still 1. F of x squared is still 1, so the point remains unchanged. F of x equals to minus 1, 1 over f of x is also minus 1. So the point remains unchanged. Now f of x squared, that point is being reflected up. Alright, the axis of reflection will be the x-axis. Now when f of x is a maximum point, 1 over f of x will become a minimum point. Whereas for f of x squared, it will still be a turning point, but you can't determine whether it's a max or min, because it can be either a max or a min. Now when f of x is a minimum, 1 over f of x will be a maximum. F of x squared can be a max or a min. Now this part, alright, f of x squared is greater than 0 for all x. This symbol, the inverted A, looks like an inverted A, alright, it means for all, alright. F of x squared is greater than 0 for all x. Of course, x must be a set of real numbers. Now this part, don't be so intimidated by this expression here. Actually, it's very simple. You just use your common sense will do. Now what I'm trying to say is that when f of x is between minus 1 and 1, if you square it, alright, it will be actually smaller than itself. Take for example, if f of x is half, f of x squared will be a quarter. A quarter is smaller than half. All right, so the f of x squared will be below the f of x graph. Now, when f of x is greater than 1, you square it, then it will be greater than itself. All right, so this is quite common sense. So don't need to memorize this. All right, as for this, I don't think you all should memorize also, because this is quite a common sense. Perhaps you just remember this part, okay? Remember this part, all right? Now, in the next video, I will show you how to sketch 1 over fx of this graph. I will also show you how to sketch fx squared of this graph. I will put the URL link in the description below. Please click on it, and I'm sure you will learn something from it. Thank you for watching. We hope to see you again.